exercise 12.3 areas related to circles. Find the area of the shaded region if PQ is equal to 24 centimeters and PR is equal to 7 centimeters. O is the center of the circle. Here we have angle RPQ is equal to 90 degrees. Since angle in a semicircle is a right angle, in right triangle RPQ, we know that the sum of squares of the two sides of a triangle is equal to square of the hypotenuse. So therefore RQ square is equal to RP square plus PQ square, where RP is equal to 7 and PQ is equal to 24. So therefore you can write it as RQ square is equal to 24 square plus 7 square, which is equal to 576 plus 49, which is equal to 625. Therefore RQ is equal to 25 centimeters. That is root of 625 you get, which is equal to 25 centimeters, which is nothing but the diameter of the circle now. So diameter of the circle is equal to 25 centimeters. So what will be the radius of the circle now? Radius of the circle will become half the diameter, that is 25 by 2. So now here we have to find out what is the area of the shaded region in the figure, from the figure. So area of the shaded region, how do we find out? We'll see. So first we have to find out what is the area of the semicircle. So in order to that, to find that, we need what is the radius of the circle. So area of the semicircle is equal to half pi r square, which is equal to half into 22 by 7 into 25 by 2 into 25 by 2 centimeter square, which is equal to 6875 by 7 centimeter square. By 28. 7 4s are 28 centimeter square. So now after finding out this, find out what is the area of the triangle, right triangle RPQ. So area of the right triangle RPQ is equal to half into base into height, which is equal to half into PR into excuse me, half into PR into PQ, which is equal to half into 7 into 24. The base into height, half base into height, you get that. So therefore that is equal to 84 centimeter square. So area of the shaded region is equal to area of the semicircle minus area of the right triangle RPQ, which is equal to 6875 by 28 minus 84. So you are getting it as equal to 4523 by 28 centimeter square, and which is nothing but it's equal to 161.53 centimeters square. .53 centimeters square. Now second problem. Find the area of the shaded region where the radii of the two concentric circles with center O are 7 centimeters and 14 centimeters respectively. So you are having here from the figure, you can see you are having two sectors. One is the bigger sector, one is the smaller sector. So the radius of the smaller sector is 7 centimeters, radius of the bigger sector is 14 centimeters. That is the shaded part which we are going to, how do we find is the area of the bigger sector minus area of the smaller sector. You will get what is the area of the shaded region. Now theta is equal to 40 degrees. So now we have area of the sector OBDO, which is the area of the smaller sector, that is equal to pi r square into theta by 360. So which is equal to 22 by 7 into, now area of the smaller circle is radius of the smaller circle is 7. So 22 by 7 into 7 into 7 into 40 by 360 will give you 154 by 9 centimeters square. Now area of the bigger sector OACO is equal to pi r2 square into theta by 360, which is equal to 22 by 7 into 14 into 14 into 40 by 360 centimeter square, which is equal to 616 centimeter square. the area of the shaded region is equal to area of sector OACO minus area of sector OBDO. So which is equal to 616 by 9 minus 154 by 9 centimeter square, which is equal to 462 by 9, which is equal to 154 by 3 centimeter square. So you are getting it as equal to 51.33 centimeter square. Now third problem. Find the area of the shaded region if ABCD is a square of side 14 centimeters and APD and BPC are semicircles. So now these two semicircles together form one full circle. So area of the square minus one area of one circle will give you the area of the shaded region, as you can see from the figure. So what is the area of the square? We'll see area of the square of side 14 centimeters is equal to 14 square, which is equal to 196 centimeter square. Now area of two semicircles, that is area of one single circle, which is equal to 2 into 1 by 2 pi r square, that is pi r square, which is equal to 22 by 7 into 7 into 7, that is equal to 154 centimeter square. So therefore area of shaded region is equal to area of the square minus area of the circle. So 196 minus 154 is equal to 42 centimeter square is the answer for this area of the shaded region of the given figure. Now next, fourth one. Find the area of the shaded region where a circular arc of radius 6 centimeters has been drawn with vertex O of an equilateral triangle OAB of side 12 centimeters. It is given that the side of an equilateral triangle is 12 centimeters. So therefore area of the equilateral triangle is equal to root 3 by 4 side square, which is equal to root 3 by 4 into 12 into 12. Now you have area of radius of the circle be r, then r is equal to 6 centimeters, therefore area is equal to pi r square, which is equal to 22 by 7 into 6 into 6, which is equal to 792 by 7 centimeter square. So now area of a sector of a circle of radius 6 centimeters of angle 60 degrees is equal to pi r square into theta by 360. Since triangle is equilateral, theta is equal to 60 degrees. So this is equal to 22 by 7 into 6 into 6 into theta by 360. So here theta is nothing but 60. So for this you know that the area of the shaded region is nothing but, required area is nothing but area of the equilateral triangle plus area of the circle minus area of the sector. So area of the sector we got it as 132 by 7. So we are minusing it from the area of triangle and area of circle, which is equal to 36 root 3 plus 792 by 7 minus 132 by 7 centimeter square. So then you are going to get it as, after taking the LCM, you are getting it as 36 root 3 plus 660 by 7 centimeter square. So therefore we are getting the answer as 94.3 plus 113.04, which is equal to, if you add both of them, you are getting it as 207.34 centimeter square. So now going into the fifth problem. From each corner of a square of side 4 centimeters, a quadrant of a circle of radius 1 centimeter is cut, and also a circle of diameter 2 centimeters is cut in the middle. Find the area of the remaining area of the circle. So now here in the middle you are having a circle of diameter 2 centimeters, therefore radius will be equal to 1 centimeters. The 4 corners quadrants are there, so 4 quadrants together will give you a circle. Therefore we have to find out what is the area of the circle, that circle also, and that circle is also having diameter here, there also it is 1 centimeters the radius. So side of a square is equal to 4 centimeters, therefore area of a square is equal to side square, which is equal to 16 centimeters square. Diameter of a circle is 2 centimeters, so radius is equal to 1 centimeter. So area of the circle is equal to, which is in the middle, which is equal to pi r square, which is equal to 22 by 7 into 1 into 1 centimeter square, which is equal to 22 by 7. Area of the 4 quadrants is nothing but it forms one circle. Here radius r is equal to 1 centimeter, so therefore it is 4 into 1 by 4 into pi r square. The area of the quadrant is 1 by 4 into pi r square. So 4 will get cancelled, you get the area of the circle pi r square, which is again you are getting it as 22 by 7 centimeter square. So now the required area is nothing but area of the whole square minus the area of the 4 quadrants plus area of the circle. This is in brackets. So therefore you are getting 16 minus 20 in brackets 22 by 7 plus 22 by 7 centimeter square, which is equal to 16 minus 44 by 7 centimeter square, which is equal to 112 minus 44 by 7 centimeter square, which is equal to 68 by 7 centimeter square, or it is equal to 9.71 centimeter square. So now going into the sixth one, in a circular table cover of radius 32 centimeters, a design is formed leaving an equilateral triangle ABC in the middle. So find the area of the design, that is the shaded region. So how do we find the area of the shaded region over here? Area of the circle minus area of the equilateral triangle. We know here what is the area of an equilateral triangle. It is nothing but equal to root 3 by 4 side square. But we have to know what is the side of an equilateral. So we know only the radius of the circle. Only that is given to us. So what we are doing is, from the center of the circle on to BC, we are drawing a perpendicular making an angle of 90 degrees. So draw OD perpendicular to BC and join OB and OC. In triangle BOD and triangle COD, OB is equal to OC, that is the radii of the circle. Now OD is equal to OD from both the circles, from both the triangles, which is common. This is one common condition, and then you are having angle ODB is equal to angle ODC, which is equal to 90 degrees. So we can tell from RHS congruent condition that triangle OBD is congruent to triangle ODC. So now you have from CPCT that BD is equal to DC by CPCT. So we can write BC is equal to 2BD. Yeah. And we also have that angle BOD is equal to angle COD, which is equal to 60 degrees, because angle made at the center is 120 degrees. It is double the angle which is made at any other point on the circle, that is 60 degrees at angle A, the vertex A it is making. So it will be double at the center. So this 120 can be divided into 2, that is 120 by 2, we are getting it as 60 degrees. So now here you have that in triangle BOD we have sin 60 is equal to BD by OB, which is equal to root 3 by 2, which is equal to BD by 32. So therefore 2BD is equal to 32 root 3, which implies BD is equal to 16 root 3. So now we get BC is equal to 2BD, which is equal to 2 into 16 root 3, which is equal to 32 root 3 centimeters. So now the side of an equilateral triangle is nothing but 32 root 3 we got. So now we will find out what is the area of the shaded part, which is equal to area of the circle minus area of the triangle ABC, which is equal to triangle ABC is an equilateral triangle. So which implies that pi r square minus root 3 by 4 side square. So which is equal to, because you know r is nothing but 32 centimeters. So 22 by 7 into r square, that is 32 into 32 minus root 3 by 4 root 3 by 4 side square, that is 32 root 3 whole square. So which is equal to 22528 by 7 minus 762 root 3 centimeter square, So after solving, how much we'll get, we'll just see. We're getting it as 22528 by 7 minus 2768 root 3. After solving, we are going to get it as 768 root 3 is equal to 2411.52, and 22528 by 7 is equal to getting this as 323218.285 minus 2411.52, which is equal to 806.76 centimeters square. So now seventh one, ABCD is a square of side 14 centimeters with centers A, B, C and D. 4 circles are drawn such that each circle touch externally 2 of the remaining 3 circles. Find the area of the shaded region. Now here with the circles there's a quadrant which is formed. So here area of the shaded region is equal to area of the square minus, it's a sector. Area of a sector of central angle 90 degrees. So here you are having not quadrants, it's a sector. Okay. So therefore here, because side of a square, angle of a square is 90 degrees. So you are minusing these 4 sectors from the area of a square. So what do we get the answer? Area of a square of side 14 centimeters is equal to nothing but 14 into 14 minus 4 into, what is the area of a sector? Pi r square into theta by 360. You know the radius of the circle is nothing but, because it is side is 14 centimeters, the radius will become half, because the side of the square is touching 2 circles externally, therefore it becomes 7 centimeters. So radius is 7 centimeters. So it is equal to pi r square into theta by 360, where theta is here 90 degrees. So that is equal to, the area of the shaded region is equal to area of square minus area 4 into area of 4 sectors, which is equal to 4 into 90 by 360 into pi r square, that is pi into 7 square. So getting 196 minus 154, which is equal to 42 centimeters. The figure depicts a racing track whose left and right ends are semicircular. The distance between the 2 inner parallel line segments is 60 meters and they are each 106 meters long. If the track is 10 meters wide, find the distance around the track along its inner edge and also the area of the track. So now for the solution here you can see the figure. The figure you can see that it is 106. The distance between the 2 inner parallel lines is 60 meters and the length of each parallel lines is 106 meters. You are having 2 semicircular edges. So these two, the first semicircle, the smaller one, is having a radius of 60 by 2, that is 30 meters radius, and the outer circular path is of radius 60 here plus 10 plus 10, so 80 by 2 is 40. So length of each parallel lines is equal to 106 meters. Width of the track is 10 meters. The distance around the track along its inner edge is equal to sum of length of the inner parallel lines minus, distance around, have to find out, no? So perimeter. So around the track along its inner edge is equal to sum of length of inner parallel lines plus 2 into semi perimeter of inner circular ends. So now this is equal to 106 plus 2 into pi into 30, that is 2 pi r, because r is equal to 60 by 2, which is equal to 30 meters. So that is equal to 212 plus 2 into 22, that is 188.57, which is equal to 405.57 meters, that is. Now second, we have to find out what is the area of the track. So in order to find out the area of the track, that is the shaded region which we are having. So you can see there are two rectangles in the area of the track and two semicircles. So the bigger semicircle minus the smaller semicircle. So area of two rectangular parts minus, so area of the track is equal to area of rectangle ABCD plus area of rectangle EFGH plus 2 into area of semicircle with radius 40 meters minus area of semicircle of radius 30 meters. So you're minusing the bigger circle from the smaller circle, you will get what is the area in the track. So which is equal to 106. So from the figure you can clearly see what is it. The rectangle part, area of the rectangle is 106 into 10 plus 106 into 10 plus 2 into area of the semi-perimeter. Semi-perimeter is how much? It is half into pi into capital R square minus half into pi into small r square. So that is equal to 1060 plus 1060 plus pi into 40 square minus 30 square. You can also write it as 40 plus 30 into 40 minus 30 into 22 by 7 is equal to 2120. So totally you are getting here, if you add everything, you are going to get it as 2120 plus 2200, which is equal to 4320 meter square. So area of the track is nothing but it's equal to 4320 meter square. So next we are going to what is the 9th problem. AB and CD so once again you can check what is this problem about. Because we are finding out the perimeter of the inner track and second we are finding out the area of the track. So in order to find out this, now next 9th one, AB and CD are two diameters of a circle with center O perpendicular to each other and OD is the diameter of the smaller circle. If OA is equal to 7 centimeters, find the area of the shaded region. So your area, the radius of the bigger circle is OA, which is 7 centimeters, and it's given that OD diameter is also 7 centimeters. So what is the area of the shaded region? Area of the shaded region is nothing but area of the circle with OD equal to 7 centimeters as diameter plus area of the semicircle minus area of the triangle ABC. So now here we have what is the area of the circle with OD equal to 7 centimeters is pi r square. So that is equal to pi into 7 by 2 whole square plus area of semicircle with AB as diameter. So here you are having OA is equal to 7 centimeters. So semicircle means half into pi r square minus area of the triangle is half base into height. So half into AB into OC. That is base is AB and height is OC. So now we are substituting all the values in the formula whichever we are having. If you are substituting, after substituting we will get it as equal to 7 by 2 is nothing but 3.5. So you are taking it as 3.5 into 3.5. Here you are taking the second, that is area of the semicircle. Here you are having radius as 7 itself. So half into 5 into 7 square. So you are getting it as finally 49 pi by 2 into half plus 1 minus 7 into 7. That is the 3 pi by 4 into 49 minus 49, which is equal to, finally you are getting it as 231 by 2 minus 49, which is equal to 66.5 centimeters square. Now 10th one, the area of an equilateral triangle ABC is 17320.5 centimeters square. With each vertex of the triangle as center, a circle is drawn with 3 lines equal to half the length of the sides of the triangle. Find the area of the shaded region. So here you have to take pi is equal to 3.14 and root 3 is equal to 17320.5, because we are taking here what is the area of an equilateral triangle is root 3 by 4 side square. So what is the side we have to find out over here? So after equating that area, what are we having? Let the side of the equilateral triangle be a centimeters. So area of the triangle is root 3 by 4 side square, and it is also given that it is equal to 1732.05. So if you substitute all this, you will get what is the side of an equilateral triangle. So which is implies that a square is equal to 49 root 3 is equal to root 3 by 4 into a square. So you are getting a square is equal to 49 into 4. So you are getting a is equal to 14 centimeters. So it is given that radius is equal to half the length of the side. So r is equal to 14 by 2, which is equal to 7 centimeters. It's also given that the area of triangle ABC is equal to 49 root 3 centimeters square. So now area of 3 sectors you are having over there, you can see from the figure, you are having 3 sectors given in the figure. So 3 into pi r square into theta by 360, because it's an equilateral triangle, you are having the angle as 60. So you are getting it as 77 centimeters square. The area of the 3 sectors. So required area is equal to area of triangle minus area of 3 sectors, which is equal to 49 root 3 minus 77 centimeters square, which is equal to 7.77 centimeter square. Now going into the 11th problem. On a square handkerchief, 9 circular designs each of radius 7 centimeters are made. Find the area of the remaining portion of the handkerchief. So here totally having how many handkerchiefs? You are having 9 handkerchiefs. I'm sorry, 9 circular design circles, not handkerchiefs. Only one square handkerchief is there. On that 9 circles are there, and each is having circular designs each of radius 7 centimeters. So diameter will be equal to 14. So 14 into 3 will give you the side of a square, length of the side of a square. So 14 into 3 means it becomes 42 centimeters, the length of the side of a square. So now area of the square is equal to 42 into 42, 1764 centimeters square. Now area of one circle is equal to pi r square, which is equal to 22 by 7 into 7 square, which is 154. Now we have to find out what is the area of 9 circles, because we have to minus it from the area of the square, which is equal to 9 into 154, which is equal to 1386 centimeters square. So area, required area is nothing but area of the square minus area of 9 circles. So remaining portion, that is without design, is equal to area of handkerchief minus area of design, which is 1764 minus 1386, which is equal to 378 centimeters square. So hence the area of the remaining portion is 378 centimeter square. So now going into the 12th one, OACB is a quadrant of a circle with center O and radius 3.5 centimeters. If OD is equal to 2 centimeters, find the area of the quadrant OACB. The shaded region, we have to find out what is the area of that shaded region. So area of the quadrant OACB is equal to pi r square by 4, or 1 by 4 into pi r square, which is equal to 1 by 4 into 22 by 7 into 3.5 whole square, because that's the radius of the circle, which is 19.625 centimeter square. Now second, what is the area of the triangle BOD? It is nothing but half the base into height. Your height is 2 centimeters. So half into 3.5 into 2, which is equal to 3.5 centimeter square. So area of the shaded portion is equal to 9.625 minus 3.5, which is equal to 6.125 centimeter square is the area of the shaded region. Now 13th one, a square OABC is inscribed in the quadrant OPBQ. If OA is equal to 20 centimeters, find the area of the shaded region, pi equal to 3.14. So here we have OA is equal to 20 centimeters and OABC is a square. So angle A is equal to 90 degrees. So we are getting OB is equal to diagonal of a square, which is equal to root of OA square plus OB square using Pythagoras theorem. OA is equal to OB. AB. OA is equal to AB, which is equal to 2 OA square under root of 2 OA square. So OB is equal to root 2 OA, and OA is nothing but 20 centimeters. It's given. So area of a quadrant OPBQ is equal to 1 by 4 pi r square, which is equal to 628 centimeters square. Area of square OABC is equal to side square, which is 20 square, which is equal to 400 centimeters square. So a required area of the shaded part is equal to area of the quadrant minus area of the square. So 628 minus 400, which is equal to 228 centimeter square is the answer. Now 14th one, AB and CD are respectively area of two concentric circles of radii 21 centimeters and 7 centimeters and center O. If angle AOB is equal to 30 degrees, find the area of the shaded region. So now here you are having the area, radius of the smaller circle is 7 centimeters for sector OCDO, and R2, that is the radius of the bigger R2 is equal to 21 centimeters, that is not 2. So for sector OBAO. So area of sector OCDO is equal to pi r square into theta by 360, which is equal to 22 by 7 into 7 into 7 into 30 by 360. So this is equal to 0, you are getting it as 12.8 centimeters square. Next, area of OABO is equal to pi r square, that is the bigger sector, which is equal to pi r square into theta by 360, which is equal to 22 by 7 into 21 into 21 into 30 by 360. So which is equal to 231 by 2, 115.5 centimeter square. So required area is equal to the bigger sector minus the area of the bigger sector minus area of the smaller sector, that is 115.5 minus 12.8. You can write over there. So required area of the shaded part is equal to area of sector OCDO minus area of sector OABO, which is equal to 308 by 3 centimeter square. Or 115.5 minus 12.8. So you are getting 102.6 centimeter square. Now ABC, 15th one. ABC is a quadrant of a circle of radius 14 centimeters and a semicircle is drawn with BC as diameter. So find the area of the shaded regions. So let points P and Q be arcs on BPC and BQC respectively, BC as diameter. So now in triangle ABC, we can see that BC square is equal to AB square plus AC square using Pythagoras theorem, because it's a right angle triangle. Over there you're having area angle in the semicircle is also 90 degrees. So you can write BC square is equal to 196 plus 196 under root, which is equal to 14 root 2 centimeters. So BC is the diameter of semicircle BC QB. Radius is equal to half of that, that is 7 root 2 centimeter square. So area of semicircle is equal to pi r square by 2, which is equal to 22 by 7 into half into 7 root 2 into 7 root 2, which is equal to 154 centimeter square. So now we got what is the area of the semicircle. Now we'll find out what is the area of this sector. The area of the sector is equal to 1 by 4 pi r square, which is equal to 1 by 4 into 22 by 7 into 14 into 14. So which is equal to 154 centimeter square. Semicircle is equal to 154 centimeter square. So area of the quadrant is 1 by 4 pi r square, which is equal to 154 centimeter square. So area of triangle ACB is equal to half into AC into AB, which is half into 14 into 14, which is 98 centimeter square. So required area is area of triangle. Therefore required area is equal to area of triangle ABC plus area of BCQB, that is area of the semicircle minus area of the quadrant. That's the sector, which is a quadrant. That is theta is equal to, it becomes 1/4 of that circle. So it's a quadrant over there. So we are going to get it as equal to 98 plus 154 minus 154, which is equal to 98 centimeter square. Calculate the area of the designed region in the figure common between the two quadrants of circles of radius 8 centimeters each. So now you have to find out what is the area of the quadrant over here. So area of quadrant ABPDA is equal to 1 by 4 pi r square. Here r is equal to 8 centimeters. So 1 by 4 pi into 8 into 8, that is 1 by 4 into 22 by 7 into 8 into 8. That is equal to 252 by 7 centimeter square. Now next we have to find out what is the area of the triangle ABD, which is equal to half into base into altitude. So which is equal to half into 8 centimeter square, which is equal to 32 centimeter square. So hence required area is equal to 2 into area of quadrant minus area of triangle ABD, because there are two quadrants and there are two triangles over there. So which is equal to 2 into 352 by 7 minus 32 centimeter square, which is equal to 2 into 352 minus 224 by 7, taking the LCM, which is equal to 2 into 128 by 7 centimeter square, which is equal to 256 by 7 centimeter square. Which is equal to 36.571 centimeter square.